So for class, Benji and I were tasked with creating something that was related to music technology. And one of the options we were given was to make a crystal radio, which is a very early entry in the technology of radio. The concepts that make a crystal radio function were first discovered in 1894 by one Jagadish Chandra Bose. He found that the crystal galena could receive microwaves. And in 1901, Jagadish filed a patent for a device that could detect electrical disturbances, which he received in 1904. And in this patent, Jagadish mentioned the crystal galena, which he had used in his discoveries in 1894 and beyond. The second person of importance in our history of the crystal radio is Greenleaf Whittier Picard, who in 1906 filed a patent for a silicon crystal detector. It included a crystal that would be used to detect the waves, and a piece of metal filament or wire that was attached to that crystal or touching it in order to detect them and run them along a circuit. And this was all held inside a case to make it a bit more stable and a bit less likely to break apart. One of the attractions of the early crystal radio was that it was inexpensive and it was a simple way to catch radio waves, which at the time in the early 1900s was just arising as a technology that people were interested in. However, at this time, it was limited to mainly academics or possibly military personnel, but that would change later on. In 1922, the U.S. Bureau of Standards released a pamphlet describing how to put together a crystal radio at home. And that was the real attraction of this. As long as you were a little handy and you were able to get the right components, you could put together a crystal radio anywhere, really. And this release from the U.S. Bureau of Standards lined up pretty close with when people consider commercial radio to have started, which was around 1920, late 1920. And so this pamphlet came out only 2 years later, which in the growing industry really helped gain more listenership for these radio broadcasts. Now, today, when people build a crystal radio, they don't generally use the crystal galena. They are more likely to use a germanium diode, which is a lot simpler and easier to use in the context of the crystal radio. With galena, or any sort of crystal as your core part of the crystal radio, you have to be very careful in tuning. And it's likely to fall out of a broadcast if you're not constantly paying attention to it. And on a side note, in Russia in the early 1920s, one Oleg Losev made something called Christodyne, I believe, that was also along the same road where it was experimenting with crystal amplification of waves. And he was successful in using the crystal zincite. And that allowed him to produce an amplification effect, which was years ahead of anybody else in this field. However, his research wasn't really supported or paid attention to, so what he discovered ended up falling out of use, and it didn't really get built upon, and it didn't lead to more technology coming from that vein, unfortunately.
So what are we looking at?
We've got all our design down. We just need to decide on what kind of antenna we're going to do, where to put it, and then we just got to put it all together.
Look, legally I'm not responsible. All right. There should be.
So what are you doing here with the drill?
For better contact and to make sure the wire stays in there,
And also so we can safely hit it with a mallet.
It went through.
But at what cost? Well, we need a hammer. Here's my proposed solution. There's still a bit in there. So we just use a bigger drill bit. Let me switch some of this wire. I gave it some length because sometimes, you might want to set up the radio and the ground's not immediately next to it.
Shalom, my fellow gamers.
Shalom! More light. Light is good.
The only dead human is a good human.
Damn. Wait.
Wait.
This earpiece?
Mhm.
Normal speakers might be like 4 or 8 ohms. This is like 10 or 20,000. Ground is connected. Now we need antenna.
How do you change what frequency it picks up?
There's 2 ways. So we have a variable capacitor here, which twisting this will like change how much metal plates engage with each other to change capacitance. And this here, by changing where we go, we effectively change the length of the inductor and the inductance. And the formula for frequency is 1 over 2 pi square root inductance and times capacitance. I can't quite hear it over the sound of the rally cars, but I definitely hear a buzz. Man. Let's double check the capacitor. When you check capacitors, they should have a pretty high resistance because capacitors work by not actually having stuff touching. So if stuff's touching and the resistance is low, that's a problem. I think I've been measuring this and put this into the spreadsheet, and if we're looking at the number of lines here, our first tap was at 15. And even there, as soon as we get to like halfway on the variable capacitor, we'll be outside the range. We didn't even try the 15th. We were at like the 25th, I think. 30th,
So a very small range.
yeah. So probably retry, make a new inductor. We'll probably lower the diameter a bit. I took apart the variable capacitor. It was toasted. So we're gonna make our own.
All right. As I was finishing up the wiring here, I kind of messed up here and I connected the positive lead to the ground here just a second ago. And I saw some smoke come out of this integrated circuit right here. So the whole thing may be out of order, but we'll have to keep going and see if it works.
Unfortunately, it didn't. This occurred after we did an in-class demonstration of the radio, so it currently does not work, but we're hoping to get it back together in the near future.